Welcome to another video. Today we're going to cover why and how to use external interrupts. All Arduino compatible boards have external interrupts available, though specific implementations can be different depending on your board. These are very useful if you need to track high-speed external events in your project, such as the encoder on a fast-moving motor or an accelerometer. The advantage of interrupts over digital and analog read is they execute when something happens, not when your code reaches it, meaning you can now track milli and microsecond events even when your code is doing something else. Here we're going to show how to set up a simple interrupt on a single pin to track when a button is pressed, and then debounce it in software without additional hardware such as an RC circuit. We're using the ESP32, which can have any pin configured as an interrupt. Other boards, such as the Arduino Uno, can only use interrupts on one or two pins, so consult your board's pinout to check its capabilities. First, we open a new project in Visual Micro and select our board and port as normal. Then, we need to initialize our pin as an input for our switch, so we use the internal pull-up here to save an external resistor. Now we can write a function to handle our interrupt event, which is known as an interrupt service routine or ISR. This function must execute very quickly, so generally we just change the state of a variable in memory. These variables should be declared as volatile as they will be changed from within the ISR. Note, ISR functions often need special declarations to ensure they are stored in memory and not flash, ensuring they execute as quickly as possible. Our interrupt will just change the state of a variable called pressed count and update a time variable as to when it was pressed with the current milliseconds. We're also adding a raw pressed count to show how often the ISR fires in reality. Now we can add our code to the setup function to attach the interrupt handler to our digital pin. This can be called when the pin changes state, goes from low to high, which is known as rising, or high to low, which is known as falling. Finally, we can add some other code to our sketch, which will act on whether the button was pushed when it gets to it. Here, we're just going to output the counts which happened during the delay. Once that's built and uploaded to our board, we can tap on the button to see our debounce count goes up by 1, and the raw count goes up a lot more, showing how often the ISR really fired due to the bouncing of the button. Don't forget to like and subscribe if you enjoyed this video, and do check out the other videos on our channel. And also don't forget to comment below if you have any suggestions or ideas for us in the future.